Hello everyone, my name is Tabassum. Today I will be presenting our ongoing work understanding configuration issues in storage systems. This is a joint work with my advisor Dr. Zheng. Storage stack is very complicated and it has many configurable components. At user level there are E2FS, Resize2FS and many other programs. In the kernel there are file system, software RAID, drivers and many other layers. Each component has many configuration parameters with wide range of values. This leads to a huge number of configuration states. As a result, it is difficult to exhaust all possible states. Many configuration related issues exist in the storage system. Here is one such example in E2FS. This bug is only triggered when two specific parameters N and E discard are used together. N is for read-only mode and discard is to discard free blocks. When executed with these two parameters, the expectation is that there would be no change when using read-only mode. But in reality, E2FS discards the free blocks unexpectedly. The state-of-the-art test suites for the storage system have limitations. We looked into several test suites, for example, E2FS procs, XFS test, and find that they only cover a small portion of the configuration parameters, which means they miss many configuration states. This brings us to the question how to test configuration related issues efficiently. To address this issue, we first studied some important components of the storage stack. We looked into their patches and source code. We performed configuration related keyword search, random sampling, manual inspection, and finally collected 70 configuration related bug patches. The first observation from our study is that many configuration related issues involve multiple components. This is a bug example which involves parameters from both make2fs and resize2fs. To trigger this bug, the sparse super2 feature has to be enabled in makefs. Then we need to expand the file system using resize2fs. This results in an inconsistent file system image with incorrect free blocks count in one block group. Our second observation is that multi-level configuration dependencies should be considered to guide configuration testing. In this example, block size needs to satisfy its own value constraint so that makefs can run properly. We call this self-dependency. Multiple parameters like resize inode and metabg also need to satisfy their relative constraints. We call this cross-parameter dependency. Moreover, to trigger this bug, sparse super2 has to be enabled in makefs, and with resize2fs we need to expand the size of the file system. Therefore, there is a cross-program dependency that needs to be satisfied. Based on our study, we designed a framework to test configuration related issue effectively. There are two major modules in our framework: static analyzer and the checkers. Static analyzer derives configuration dependencies from the source code to prioritize some configuration states for effective testing. And checkers check configuration related issues based on the dependencies. Our static analyzer is based on LLVM, where we generate chain traces for each parameter and establish a relationship among them. From the taint analysis, we identify the configuration dependencies. With our prototype, we already identified several self, cross-parameter, and cross-program dependency in multiple programs. In our prototype, we have two checkers. In the config handle checker, we intentionally violate the configuration dependencies. And this is to test whether the target software can handle the wrong configuration properly. In the configuration bug checker, we follow the configuration dependencies. And this is to dive deep into the source code to expose configuration related issues effectively. Due to time limit, I will skip the details for now. There are many related work, but they are suboptimal at addressing the configuration issues in the storage stack. For example, some of them focus on single application, some of them focus on performance related configuration, and some are not publicly available. To conclude, We observed that many cases involve multiple components and multi-level dependencies can be leveraged for effective testing. In our future work, we will fully implement our prototype with minimum manual annotation, and we will apply our prototype on various storage system components. This concludes my presentation. Thank you.